Hi, hello, and welcome to MathLink. I'm Nitya, and in this video, we will share the basic foundation of matrix concepts. And if you are interested to know about the history behind, don't forget to watch our previous video. It's already here. So let's begin. Here we have 4 different airports in India. We have Kochi, Mumbai, Delhi, and Jaipur. Let me seek your attention to an imaginary station where a flight originated from Kochi to Mumbai. After landing in Mumbai, it may operate as a Mumbai-Delhi flight. And after landing in Delhi, it may operate as a Delhi to Jaipur flight. That is Delhi-Jaipur flight. The same way, the return flight will also operate. That is from Jaipur to Delhi, Delhi to Mumbai, and Mumbai to Kochi. And those are represented using the pink lines here. Okay. Now the question is, how can we convert this diagram in a well-structured manner? If I want to convert this data or if I want to save this data in form of a well-structured manner in a computer, what shall I do for that? Yes, we have to make a table using this data. For that, we have to construct rows and columns using the names of these 4 airports, that is Kochi, Mumbai, Delhi, and Jaipur. Before that, let me remind you about rows and columns. Rows are the arrangement of data. It can be data, it can be any facts, it can be anything. The arrangement of numbers, data, or facts in a horizontal manner. A horizontal line means a line which is parallel to the surface. Okay. In same way, columns. Columns are the arrangement of data, facts, or numbers, or anything in a perpendicular line, in a vertical line. Okay. The arrangement of data in a vertical line. What do you mean by a vertical line? Vertical line means a line which is perpendicular to the surface. A line which is perpendicular. This is a vertical line. Okay. So here we have to construct a table using these 4 airport names as rows and columns. Let's start this. So at first, we have this Kochi, Mumbai, Delhi, Jaipur as the row names. And then the same Kochi, Mumbai, Delhi, Jaipur as the column names. And Kochi to Kochi, it's an absurd thing, right? There is no logic behind Kochi to Kochi, the same airport to itself. So the data, it will be 0. Okay. So the representation here will be 0. And Kochi to Mumbai, 1. Kochi to Delhi, nothing here, so 0. Kochi to Jaipur, again 0. And Mumbai to Kochi, 1 again. Mumbai to Mumbai, 0. Mumbai to Delhi, 1. And Mumbai to Jaipur, 0. Delhi to Kochi, 0. Delhi to Mumbai, 1. And Delhi to Delhi, 0. Delhi to Jaipur, 1. Jaipur to Kochi, 0. Jaipur to Mumbai, 0 again. Jaipur to Delhi, 1. And Jaipur to Jaipur, 0. See, this arrangement is nothing other than a matrix form. So what will be a matrix? A matrix means the arrangement of data in a tabular form. That means the arrangement of data in a table. The data will be arranged using a table. That's what we call a matrix. Okay. But to make it simpler, what we are doing is we are just eliminating this row names and column names in a matrix form. In matrix form, we will be eliminating these rows and column names and we will enclose this data. This entire data will be enclosed within closed braces like this. 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, and 0, 0, 1, 0. 0, 1, 0. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0 I think it's clear. So a matrix means, matrix is the conversion of data in a tabular form like this. And the data will be enclosed within closed braces. Now you might be thinking, what are the needs of converting this information into a tabular form, right? See, we need matrix concept in our daily life. We use it knowingly or unknowingly in so many different ways in our daily life. And we have one direct application of matrices, that is cryptography. See, what is cryptography? Cryptography is the process of hiding information for security purposes. See, using this cryptography, we can use a matrix to make the information to be readable only to the recipient. So using this matrix, we can hide a particular piece of information and you can make that information to be readable only to the recipient. So this matrix concept is very much useful for security purposes. And we use the same matrix concept knowingly or unknowingly in our daily lives. I had already told about that. For example, when you are watching a Republic Parade or when you are watching a movie in a movie theater, see, you can see the same arrangement there. For example, when you go to a movie theater, you will show your ticket to a ticket checker and he will tell you like that. You have to sit at the third row, sixth seat. So unknowingly, we are using the same matrix concept here. So not only that, these matrices have so many applications in quantum physics, optics, and battery usage, and what else, gaming, computer graphics, in all those fields that we will discuss clearly in coming videos. Now let's see how to convert this data into matrix form. First statement is Ajay has 6 pens. So how can we construct a table using this data? Ajay here and pens here. So Ajay has 6 pens. So this is a table. And to convert this into matrix form, what to do? I have already told you, matrix is nothing other than the data enclosed within closed braces. So it is 6 enclosed within closed braces. That is a matrix form. Now the second one, Ajay has 6 pens and 5 pencils. So we have Ajay here. We have Ajay as the row name, and pens here and pencils as column names. So Ajay has 6 pens and 5 pencils. So how to convert it in matrix form? It is simply matrix 6, 5. Now the third one, Ajay has 6 pens and 5 pencils. Rima has 4 pens and 3 pencils. So we have 2 rows, Ajay and Rima. And we have 2 columns, pens and pencils. So Ajay has 6 pens and 5 pencils. Rima has 4 pens and 3 pencils. No matrix form. Matrix 6, 5, 4, 3. Now the last one was Ajay and Rima, columns, pens and pencils. So Ajay has 6 pens and Rima has 3 pens and 2 pencils. So we cannot construct a table using this incomplete data. So we cannot even construct a matrix either. Okay, so you cannot construct a matrix like this. You cannot leave this space as vacant. So we cannot construct a matrix without the complete data. So in a matrix, you cannot leave a space as vacant. Now I'm giving you some examples and you have to tell me if it's a matrix or not. First one is a matrix. What about the second one? Second one is a matrix. Yes. And the third one, it's a matrix. Fourth one, this is not a matrix because this entry, you don't know anything about this entry. It is vacant. So this is not a matrix. And the last one also, it's not a matrix because it is incomplete. Okay. So how can you define a matrix then? See, using this data, using these examples, can you define a matrix? See, we can say that the first one is a matrix, second one, and the third one is a matrix. So we can say that this matrix is a rectangular. All these looks like a rectangle, right? So matrix is a rectangular arrangement of numbers. Is it right? So we can say that matrix is a simple rectangular arrangement of numbers. See, not only numbers, we can have characters, we can have functions, we can have names or anything. Okay, inside closed braces in a matrix. So matrix is a rectangular arrangement of numbers, functions, characters, variables or anything. Here we have some more examples for matrices. All these things are examples of matrices. Now, how can you define a matrix in rows and column? Let's see. In first one, we have 2 rows and 2 columns. This is first row, this is second row, and this is first column, and this is the second column. And in each row, we have 2 elements. Here 2, here 2. And in each column, we have 2 elements. And this is a matrix, okay? So, one more example. And here we have first row, second row, 2 rows. And in each row, we have 3 elements. And in each column, we have 2 entries. And what about this? This is not a matrix because this entry is vacant. So how can you define a matrix in terms of rows and columns? We can define a matrix in terms of rows and columns like this. A matrix is a rectangular arrangement of rows and columns in which each row and each column must have equal number of elements. See, in this example, the first row has 2 elements, but the second row has just 1 element. So this is not a matrix. Matrix is a rectangular arrangement of rows and columns in which each row and each column has same number of elements. See, your name is your primary identity, right? Your name helps you to differentiate from others. So likewise, the primary identity of a matrix is its name. And it's very easy to name a matrix. It's very easy to name a matrix. We can use any uppercase letters for naming a matrix. We'll show you one example. We have a matrix 3, -8, 9, 6. You can name this matrix as uppercase letter X equals 3, -8, 9, 6. Or you can use any alphabet like A equals 1, 2, or C equals matrix 8, like that. So the primary identity of a matrix is its name, and we usually represent a matrix using uppercase letters. And matrices have one more identity, and that is its order. Matrix 1, 2, 0, 4, 3, 2, -3, 8. And the order of this matrix is 2 by 4. This is just a representation, and we usually read it as 2 by 4. Okay, how you got this 2 and 4? We'll show you. Here this 2 is the number of rows of this matrix. We have 2 rows here, first row, second row. And this 4 is the number of columns here. This is first column, second column, third column, and the fourth column. So this matrix has 2 rows and 4 columns. So the order of this matrix is 2 by 4. And we usually write it at the right bottom corner of this matrix. This 2 by 4 is the order of this matrix. And there is no need to multiply. See, don't write like 2 into 4 equals 8. Okay, this is just a representation. It is 2 by 4. See, but when you multiply these 2 digits, you can see one thing. This 8 will be the total number of elements in this matrix. So when you multiply these 2 digits, you will get the total number of elements in this matrix. Okay, we'll give you one more example. Another matrix 1, 3, negative 8, 5, 6, 0, 0, 2, and 1, 3, 8, 6. Now tell me the order of this matrix. This matrix has 3 rows. First row, second row, and third row. So 3 here, 3 by. Now columns. How many columns are there? 1, 2, 3, 4. So 3 by 4 is the order of this matrix. And when you multiply this 3 by 4, you will get the total number of this matrix, total number of elements of this matrix. I think it's clear. Symbolically, we can represent the order of a matrix, as M by N, where M is the total number of rows of this matrix and N is the total number of columns of this matrix. So I think this is clear. Order of a matrix, it is M by N, where M is the total number of rows and N is the total number of columns. Now the last topic of this session, elements of a matrix. Elements of a matrix. Each and every member of a matrix is known as its elements. We can even use the term entries . But it's rarely used. Most commonly, we are using the term elements. So each and every member of a matrix is known as its elements. An example. Here in this matrix, 1 is an element of this matrix, and 3, 8, 6, 5, and 0 all are elements of this matrix. There is one symbolic representation of elements of a matrix, that is A, I, J, where I is the respective row number and J is the respective column number. Using this, how can you express this 1? So this 1 is intersection of first row, first column, that is A11. What about 3? First row, second column, right? 3 belongs to the first row, second column. So 3 is A1, 2. What about this 8? 8 is A1, 3. 8 is the intersection of first row, third column. So 8 is A13, like that. 6 is A21. That is, the 6 belongs to the second row, first column, like that. Okay, now tell me what is A23? A23. A23 here is A23. A23 is the intersection of second row, third column, right? Second row and third column. This is second row and third column is here. So this intersection is 5. So A23 is 5. What about A21? A21, second row, this is row and this is column. Second row, first column. Second row here, first column is here. So the intersection of second row, first column, that is 2. I think it's clear. Using this elements notation, we can symbolically represent a matrix like this. Matrix. The first element will be A11. Okay, the intersection of first row, first column. Second one will be A12. The intersection of first row, second column. That is A12. Now third element will be A13. And we don't know how many elements are here. So we express it as A1n. Okay, that is elements that comes under first row, nth column. So what about the second row? It is A21, A22, A23, and the last element of this row will be A2n. It's just because we don't know how many elements are there. That's why we are representing the last element, last column by n. And the same thing with this rows. We don't know how many rows are here. So the last row, we are putting a name like M. So last one will be AM1, then AM2, AM3, AMN. This is the symbolic representation of a matrix, where A11 is the intersection of first row, first column, A12 intersection of first row, second column, like that. AMN, the intersection of first mth row, nth column, where M is the final row number and N is the final column number. This is the symbolic representation of a matrix. For A11, A11 is the intersection of first row, first column. A12, the intersection of first row, second column. A13, intersection of first row, third column, like that. For M is the last row number. Last row number means, yes, if this is a matrix, 1, 2, 3, 3, 4, 5. We have 2 rows here, first and second. So last row number means 2 here, like that. Okay. So here we don't know anything about the number of rows and columns. That is why we just symbolically represent a matrix like this. And that's all. Thank you so much for watching this video. If you have found this video as informative, don't forget to subscribe our channel. And you can even share your opinions, your views, and your suggestions using the comment section below. And you can even share your doubts regarding this topic using the comment section below. And once again, thank you. See you. Bye-bye.